Yeah, all right. I have tried to record 3 times. This is my third attempt. Hopefully OBS won't suddenly quit on me. But this is why this channel's here, partly, so that I can experiment with the equipment and get it all working after I run around the country for 3 weeks with all my equipment and then set it back up again when I get home. So, what I wanted to talk about today was a little bit of history, just a touch, between Cisc and Risc. A lot of people don't understand what happened there, and because I was there and I remember this, I figured I'd talk about it. So, effectively, Cisc, which is obviously the superior technology, um, had a battle with Risc because of some theoretical uh, statements and math that was dumb. So what happened was they said, look, on paper, a RISC system is much quicker because it's one instruction per clock cycle. That's the original definition. And so what happens is you're more deterministic. You can get better time slicing out of it. Right? There's a ton of theoretical advantages with RISC. Now, the problem with RISC is that RISC processors use way more memory to do the same amount of work because you just have many, many, many smaller instructions. And so you've moved the complexity from the silicon, where it's faster, by the way, to the compiler. Now, it doesn't necessarily have a bad effect, except there is a problem. It's not just more memory, right? Because whenever you take up more memory, you also use more bus. That's the issue, right? So in order to get the stuff to the CPU, and remember we're dealing with von Neumann load and store architecture stuff, so there's a data cache and there's a execution cache, right, for the actual stuff, the operations on the data. And so now you have more operations because they're tinier. That's what RISC amounts to. It's not exactly the same, but that's what it amounts to. And so you just have fewer instructions. But then there's an additional problem. So die sizes were increasing to accommodate Cisc instruction sets so that you can send fewer instructions over the bus and they can do more with less data. Things like SIMD, for example, right? Single instruction, multiple data. SIMD instructions tend to be rather complicated, multi-cycle instructions. That's fine because all that stuff's on chip in cache, which is a big deal. On die cache usually, right? That's a big deal. So what ends up happening is um, your RISC core only needs to be this big, but you have this much die, and it's like, well, what are you doing, right? Now the obvious thing would be to put more memory on the die, but back then, for whatever reason, they didn't. I don't know the technical details. I'm sure there was an actual reason. Um, and so what you got was Sun Microsystems Spark. Now, Spark is the bane of all good things in the world. That's because they had to rewrite everything, and the machines were unbelievably slow. So you had to have a lot of memory, like a lot more memory, to do the same thing. So if you take like an old Spark Station 10 or Spark Station 20, I think I have a Spark Station. I have a Spark Station something. Oh no, wait a minute. What am I saying? You take an old Sun Workstation 10, which is 68,000 based, and you run open Windows on it. I think it's 4.11, maybe 4.13 was the last version. I don't know. I have one in the shed. Maybe I'll get it working someday. And then you run that versus a Spark Station equivalent from it was made just after that, right? 2 years later or something. There's no comparison. The Spark is pig slow. It's horribly slow. And we can get into, well, it's the compiler, it's a new technology, blah, 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 all day long. But the bottom line is the RISC is slow. So what Sun did, wisely, was they just put more cores on everything. So, you want to talk about 12-core machines. It's Sun had 12-core workstations back in the early 90s or something stupid. Like they had the Spark stations went multi-core real fast because they were RISC instruction set. And so they were fantastically expensive machines because not only did you have a low production processor, even though it was cheaper to produce, at least in theory. I don't know what the numbers ended up being, but in theory, it's a lot cheaper to produce a RISC system. You had to have way more memory, like twice as much. Like it's really bad, right? And so to run a program that would run in 4 megs on a 68,000, you need 8 megs of memory, right? It's that bad. And so what happened was it didn't go anywhere. Multi-core software wasn't a thing, except in the workstation land where it was, but it took them years to get p-threads and work all that stuff out, and those are all better ideas than containers, but whatever, different video. So that's sort of some of the battle back and forth. It wasn't cheaper, it wasn't faster, it was more real time. I mean, some of these Sun systems were running very large, super scale. All the early web servers were running Sun workstations, Sun Spark stuff, because it was really able to handle lots of transactions per second with high accuracy and high throughput. At the cost of, I mean, those machines were $30,000 or something, I think, back in the day. Like they were hugely expensive. You could buy a PC for $1,200, and better yet, you could buy an Amiga and then have something even better. So if you're dealing with equivalent stuff, the Next workstations were 68,000 based, and they were way better than the Suns. Like Next and the software on the Next really transformed computing completely, and that's all Cisc based stuff, right? So when you sort of count it up, a RISC is basically a mistake unless you need a high core count and you don't care how much memory you use. And maybe nowadays that's appropriate, but back then, no, memory was the most expensive thing in a computer back in the 90s and the 80s. It was my stepfather told me a story. Some of the first core memory went to MIT when he was at MIT, and he was there watching him take it out of the armored vehicle. It was $1 million board. It was one board. I was like, what? So memory was always super expensive. So memory is super hard to make. So it's good to know why the RISC thing didn't take off. And now maybe, like I said, maybe the game has changed and RISC is okay. And certainly GPUs are a RISC-like architecture, very light. And Cisc clearly got out of control, right? Because they kept trying to maintain compatibility. And then they had a number of, we'll call them questionable engineers designing some of these Cisc instructions. And then if you want the ultimate system, it's the Alpha. The DEC Alpha chip is the best of both worlds. It's a RISC underneath, and it's a Cisc in the firmware. And so you're sending Cisc instructions into the thing, and then it's figuring out way better stuff. Like because it's on die, and because it's in microcode, which you can update, by the way, which I think is where Intel got it from, but I don't know for sure. You can update the microcode on the Alpha, but because it's in microcode, the processor can actually be aware of scheduling things and how to do that more efficiently than you could do from a compiler, because a compiler is only aware of its own software. It's not aware of all the other software that's running. And so there's all kinds of neat optimizations that the Alpha does. I mean, the Alpha performance for everything else of its time, Alpha's awesome. I have 2 Alpha machines. Only one of them have I seen work. The other one, I don't think I ever got it to work. Maybe someday. It's all that stuff's in the shed. So I think it's important to realize, like, we've been on this merry-go-round before, right? And maybe next time, if you want to see it, containers, I'll talk about containers and the history there, because that's all, of course, wrapped up in Sun as well. So yeah, if you don't know the history of containers in Sun, which is the result of them choosing a RISC architecture, like explicitly, because they needed to go high core count, right? And then it was the right answer. Like that was the right answer for them and the decisions they made. Whether or not they should have gone RISC, I'm still a no. But a lot of good things came out of it. There's no question about it. Like Sun's an amazing company. They had great engineers. I loved working with them. Too bad they're gone. Java was a horrific mistake that has cost the world everything. But other than that, they have a decent enough track record. But like that's where all this stuff comes from. So I think it's just important to keep in mind. So yeah, if you want to see something on containers and sort of the brief overview history of that, let me know in the comments, and I'll give it a shot.